Let's solve the differential equation d squared, y over dx squared plus 18, y equals 0. This is a second-order linear homogeneous differential equation with constant coefficients. To solve this equation, we'll use the characteristic equation method. First, we replace the second derivative with our squared, and y with 1, giving us our squared plus 18 equals 0. Now, let's solve this quadratic equation. First, subtract 18 from both sides. Then take the square root of both sides. This gives us our equals plus or minus the square root of negative 18, which equals plus or minus 3 times the square root of 2i. Since we have purely imaginary roots, the general solution will be in terms of sine and cosine functions. The general solution is y equals c1 cosine of 3 root 2x plus c2 sine of 3 root 2x, where c1 and c2 are arbitrary constants. Let's visualize what this solution looks like. Here's the graph for different values of c1 and c2. The blue curve shows when c1 equals 1 and c2 equals 0, giving us just the cosine term. The red curve shows when c1 equals 0 and c2 equals 1, giving us just the sine term. And the green curve shows when c1 equals 1 and c2 equals 1, giving us the sum of both terms. Notice how all solutions are periodic, which is characteristic of differential equations with purely imaginary roots. This means the solution represents harmonic motion with a period of 2 pi over 3 root 2.